You ever use an app and it just feels instant, while another one leaves you staring at that dreaded loading spinner? Well, the secret to that speed often isn't just about having bigger servers. It's about a really clever piece of architecture, a middleman that works behind the scenes. In this explainer, we are going to pull back the curtain on the logic of this unsung hero, and you'll see how it's absolutely key to building apps that are not just fast, but truly resilient.
We've all been there, right? You click a button, and nothing. The whole app just hangs. That spinning wheel you're staring at is a classic symptom of what we call a brittle architecture. It's a system that treats every single little task as a top priority emergency. And as this quote puts it so perfectly, that inability to tell the difference between what needs to happen right now and what can wait a second, that's exactly what causes it to break. And that costs you users, and it definitely costs you money. So how do we fix this? How do we build something that's not brittle? Well, it all comes down to understanding two very different ways of communicating. On one side, you've got the synchronous model. Think of this like a restaurant waiter. He takes your order, and then he literally stands there at your table, waiting for the kitchen. He is completely blocked. He can't go get drinks for another table. He can't take another order, nothing. Your one request has frozen him. Now look at the other side, the asynchronous model. This is your fast food pager. They take your order, hand you that little buzzing coaster, and immediately move on to the next person. You're free, they're free, and the kitchen is working completely independently. The whole system is non-blocking. This one simple analogy, this is the secret weapon for a resilient architecture.
Okay, so here's the journey we're going on today. We've just talked about the architect's dilemma. Next up, we're going to dig into the logic of that middleman. Then we'll explore the 3 key strategies it uses, see how this whole thing scales beautifully, and finally, we'll wrap it all up in your very own architect's toolkit.
All right, let's dive right in. Time to really unpack the logic of that middleman. This is where we get to the core technology that makes that whole fast food pager model a reality in our software. We're talking about the AMQP Broker. So, what in the world is an AMQP Broker? The best way to think about it is as a super smart, super reliable postal service for your application's data. It's this central server, right? And it accepts messages from senders, we call them producers, and it takes on the entire responsibility of getting them to the right recipients or consumers. It makes sure the mail gets delivered, period. And that means if the recipient is busy or offline or even crashes, the broker just holds on to that message safe and sound until it can be delivered. The sender sends it and can completely forget about it.
Now to really get this, we gotta look inside the broker. It's not just some black box. It really has 2 main parts that do very different jobs. First up is the exchange. Think of this as the main sorting facility at the post office. Its only job is routing logic. It looks at the address on a message and figures out exactly where it needs to go. Then you have the queue. The queue is the actual mailbox. Its job is storage. It's just a safe place, a buffer, that holds onto those messages until the recipient is ready for them. This separation, logic over here, storage over there, is fundamental to why this system is so powerful.
Okay, now this next part is maybe the single most common point of confusion for folks new to this, so let's be super clear. The routing key and the binding key. They sound similar, but they are not the same thing. The routing key is the address on the envelope. The sender, the producer, writes this address on the message before sending it. It's a direct instruction for the exchange. The binding key, on the other hand, is the filter on the mailbox. The queue itself sets up this filter to tell the exchange, hey, I am only interested in messages that match this pattern. One is set by the sender, the other by the receiver. Getting this distinction right is the key to everything that comes next.
So, now that we've got our building blocks, the exchange for logic, the queue for storage, and the keys for addressing, let's see how they all play together. We're going to look at the 3 main routing strategies, or exchange types, that give us a tool for pretty much any situation you can think of. Let's call it the exchange triple threat. First on the list is the direct exchange. This one is the simplest. It's the most precise tool you have. It follows one very simple rule. It will only send a message to a queue if that message's routing key is an exact character-for-character match for the queue's binding key. No wildcards, no funny business. If you need perfect point-to-point delivery, this is your tool.
And you can immediately see where this precision becomes critical, right? Let's say you're dealing with financial data. A message with the routing key, APL, better go only to the queue that's specifically subscribed with the binding key, APL. Any other behavior would be a serious problem. Or think about sending a print job. A document sent with the key printer.lab1 needs to go to the printer in lab 1 and absolutely nowhere else. That's the power of the direct exchange. Perfect one-to-one delivery.
All right, next up we have the polar opposite, the fan-out exchange.
I like to call this one the broadcast hub. And why? Because it could not care less about routing keys or binding keys. It completely ignores them. Its job is dead simple. It gets a message, it makes a copy, and it sends that copy to every single queue that's connected to it. It is pure one-to-many broadcast.
So when would you ever use this? Think about situations that require mass notification. A single tornado warning message gets sent to a Fanout exchange, and boom, it's instantly delivered to separate queues that handle SMS alerts, email blasts, and maybe even physical emergency sirens. The sender doesn't need to know about all those different systems. It just screams tornado once, and the exchange does all the hard work of fanning it out. It's unbelievably useful.
And that brings us to our third and final type, which is arguably the most flexible and powerful of them all, the topic exchange. You can think of this one as the pattern matcher. It doesn't care about exact matches, and it's not just a blind broadcast. Instead, it uses wildcards in the binding keys to intelligently route messages based on the pattern of the routing key. This lets you build some incredibly sophisticated and dynamic routing systems.
Now, to really use the topic exchange, you have to get the two wildcards right. This is mission critical. Let's start with the asterisk. The asterisk replaces exactly one word, and words are just things separated by dots. So if a queue's binding key is truck.as.engine, it's going to match a routing key like truck.001.engine. But it will not match truck.tires. See? Now let's look at the hash symbol. This is where the real magic is. The hash replaces 0 or more words. That means a binding key of auth.hash is like a giant net. It will catch everything that starts with auth. Auth.login, auth.logout.success, even auth.failure.timeout. Understanding the difference between exactly 1 and 0 or more is the whole ballgame.
And here's where that wildcard wisdom really pays off in the real world. Imagine you're monitoring a huge fleet of trucks. A queue bound to truck.asterisk.engine with the asterisk can listen for all engine-related events from every single truck without needing to know the specific truck ID. Or what about a unified error log? A single queue bound to asterisk.error can collect every single error message from your entire system, whether it's an order.error or a shipping.error. It is an incredibly elegant way to aggregate related information from lots of different places.
Okay, so we've built this awesome, decoupled, resilient system. But what happens next? What happens when we succeed? When our app gets popular and messages start flooding in? That brings us to our next section, scaling with grace.
This is the question that keeps every good architect up at night. Your app is a smash hit, messages are pouring into your queues, and that one single worker you started with just can't process them fast enough. The queue starts backing up, getting longer and longer. So, what do you do?
And here is the beautiful, beautiful answer. The solution is already there. It's built right in. As this quote points out, your AMQP Broker is a native load balancer. This is a huge deal. You don't need to go out and buy, configure, and manage expensive, separate load balancing hardware for all your background workers. That logic is baked right into the system you're already using. Let me show you how it works.
Let's just watch this happen. Imagine we have one queue and it's got 6 messages waiting. To handle this load, we just launched 3 identical consumers, and they all listen to that exact same queue. Now watch what the broker does all by itself. It uses a simple but brilliant method called round robin. The first message, bam, goes to consumer 1. The second message comes in, you got it, goes to consumer 2. Message 3 to consumer 3. And then it just loops back to the beginning. Message 4 heads back to consumer 1, message 5 to consumer 2, and 6 to consumer 3. The workload is shared perfectly evenly, and we did 0 complex configuration. And if the traffic gets even heavier, we just spin up a 4th consumer, and the broker will automatically include it in the rotation. It's amazing.
And that brings us to the home stretch. Let's pull everything we've just learned together into a nice, practical toolkit you can use to really master these ideas.
So here's a quick cheat sheet. Remember, the broker is that central postal server. Inside it, the exchange handles the logic, while the queue handles the storage. And the big one? The routing key is the address put on the envelope by the sender, while the binding key is the filter put on the mailbox by the queue.
All right, time for a quick self-check. Can you explain temporal decoupling? It's just a fancy way of saying the sender and receiver don't need to be online at the same time. The broker handles that. Can you clearly explain the difference between an exchange for logic and a queue for storage? Do you really truly know the difference between a routing key from the sender and a binding key on the queue? Do you know exactly when you'd use an asterisk versus a hash in a topic exchange? And finally, Can you explain how that round-robin trick gives you a free, built-in load balancer? If you can nod your head yes to these, you've got this.
So let's end with what's probably the most important takeaway of all. This isn't just some abstract back-end theory. This is all about the user's experience. So here's your pro tip. Anytime a user does something and they don't need to see the result of that action to move on, send that task to a broker. Things like sending an email, processing a photo, generating a report, offload it. This is the secret to a snappy UI. By pushing all that heavy lifting into the background, you make sure the user is never stuck waiting. You're not just building a resilient system, you're building a system that feels amazing to use. And really, that's the whole point.